I will be recording today's lesson, so if you, again, as usual, aren't comfortable being recorded or don't want to be recorded, just send me a chat. So I just want to make sure of that. Today's lecture will be on vector addition. And vector addition is when you have multiple vectors represented by a resultant vector. So you remember last time we had components and a resultant was a single force that represented multiple forces. Well, the same thing is true with vector addition, right? The way we're going to write it is R equals A plus B plus C. So A, B, and C, those would be individual vectors, and R is the resultant vector. So it's one vector, again, representing multiple vectors. We're going to be using what we call the component method, where we break down each of the individual vectors into their components, and then we add the components and use those components to find the resultant. So those components of each individual vector, when they're added, come up to be the resultant's components. And if you watch the video on this, it shows you really well how the components move around. And that's what we're going to do, and we will just start with a actual example. So let's say, a lot of times we'll just represent it with a box, and I'll put two vectors on here. I'll make it easy to start. We'll have vector A and vector B. Let's say vector A is 8 miles, and vector B is 11 miles, and vector B is at, let's call it 70 degrees. 70 degrees. So what we want to do is we want to find one vector that is these two together. So R equals A plus B. And what I'll show you in the lab is that what you're going to do is you're going to take these two vectors, we'll take this, A, and then you add B to the head of A. And mine aren't drawn to scale, right? I think this is long. 11 should be a little bit longer than 8. So 11 should be like that. And then your resultant vector is going to go from start to finish. So that's your resultant vector there at some angle theta. And that's what we're solving for. And if you take AX, so AX goes to the left and then BX goes back to the right, this little increment here, it's going to be hard to draw just because I don't know if they're going to go on top, but this increment here, that's AX minus BX. And then AY, well, you can see AY is 0, so BY is going to equal RY. So that little vector triangle for R there, that is what we're solving for. This is how you do it graphically. This is what we're going to do in the lab. Now, you wouldn't put these two in. So you would draw A, and then at the head of A, you make a coordinate axis, and then you draw B, and then you draw R from start to finish, and you would measure R. That's called the graphical method of vector addition. You actually physically draw them out. The component method, which we wanted to talk about over here, right? This is the component method. This is mathematically how we're going to solve it. So I'm going to show you how to solve this mathematically. So let me just move these back to where they were. It went off the screen. I made it too big. And just remember that value for R was in the second quadrant. So what we want to do here is we are going to solve this the component method. And we're just going to take our little picture here, move it over, and use the rest of this to do it. B, vector B, is broken down into its components, bx and by, right? That's vector B, where we know from what we learned earlier from last section that bx equals 11 cosine 70 and by equals 11 sine of 70. And those are our two components of B. A, the y component of A, is 0. So the way that we solve this using the component method is we create a little graph or a chart. So I'm just going to make a little chart here. And in this chart, I'm going to have my x values, and this is in miles, and my y values, that's in miles, and my vectors are A, B, and then our resultant vector. That's what we're solving for. So what we're going to do is solve these vertically. So AX, we can see over there, is -8, and AY is 0. BX, which we have down there at the bottom, BX is 11 cosine 70, and BY is 11 sine of 70. Now we want to add these together. And we get -4.24 for Rx. And Ry is 10.34. You can see that this puts us into the second quadrant, just like we thought in, or like we had in our previous problem, right? Rx is to the left, Ry is up, and that makes R go from start to finish. That's our value for R. Now our goal is to find the magnitude, quadrant, and angle for R. So remember how to do that from last lesson. If we go for R squared equals x squared plus y squared. R squared equals 4.24 squared plus 10.34 squared. R equals 11.17 miles, and tan theta equals y over x. So theta equals inverse tangent, running out of room, 10.34 divided by 4.24. Theta equals 67.70 degrees. So R equals 11.17 meters at an angle in the second quadrant of 67.70 degrees. And this is how we solve vector addition. We just add them right on up. Add up the components, solve it, and go through. There's nothing really super difficult about it. The hardest part is making sure you have your negatives and your positives correct with your components. Remember we mentioned that last time that that's important to do, and this is why. Does anybody need anything clarified on that? All right, so we're going to try another one here. We'll do it together. Oh, we'll do a circle this time. And vectors. We'll make some vectors coming off here. We'll do 3 of them. 1, 2, 3. And I'll make them a certain. A is 2 meters per second. I'll come down here. B equals 1.7 meters per second. And over here, C equals 2.2 meters per second. And then I got to put angles in here. So this one here. Make that 50 degrees, and this one's 60 degrees. So those are our 3 vectors. They're acting at 2 angles, 50 degrees and 60 degrees, 2 of them. B is not at an angle, it's horizontal. And now our goal is to solve for the resultant, or one vector that represents all the vectors. That's our goal. All right. So we're going to make our chart. So I'll just come over here and draw out a chart. I don't necessarily want to do this in red. Let's make it in lavender. We don't use lavender enough. 1, 2, 3, and then we get R at the bottom. Not the straightest line, but it doesn't matter. So we have our chart. We're going to insert our values for A. We got B. We got C. X in meters per second. And Y in meters per second. Now we got to fill in our values for our components. We'll start with A. Well, A has a negative X, positive Y. So this is -2 cosine 50 and +2 sine of 50. B has a negative X, -1.7, and Y is 0. And then C is positive X, 2.2 cosine 60. And we have a negative Y, 2.2 sine of 60. Our goal is to find the components of R. So we're just going to mathematically solve or sum up these numbers. I get -1.89 for R. X, or X, I should say. And RY, this could be really close to 0. -1.33. That doesn't seem right. Yeah, -0.37. -0.37 sounds better. So you can see we have a third quadrant resultant. Even though we don't even have a force in the third quadrant, our resultant is in the third quadrant. We have a negative X, negative Y, and our resultant goes from start to finish. So that's R. Now we have to solve for R using our math. R squared equals 1.89 squared plus 0.37 squared. R equals 1.93 meters per second. And then tan theta equals 0.37 over 1.89. 11.08 degrees. So R equals 1.93 meters per second at an angle in the third quadrant, 11.08 degrees. And you can see from our picture over here, our math looks pretty close to the picture we sketched out. Anybody have any questions there? Give me a thumbs up if you think you can do one on your own. Come on. It's only half. I think everybody can do one on their own. We're going to try. We're going to try. All right, so let's go back to the screen. I'm going to put a new one up here. This time you guys are going to do this at your seats. Put it in the middle of the screen more. We'll do 4 of them. Let me get some values out here. A, 5 meters. We'll do B equals less than that, 20 meters. C, 17 meters. And D looks about like 20 meters too. I'm going to do another 20 meters. 20 meters. And I got to put some angles in here. I know you guys are loving the new typing instead of me writing all that slop. I figured out how to do some more things. Let's make this angle here, I don't know, 25 degrees. I don't know how to do a degree sign. And then this angle here looks more like 55 degrees. All right, give that one a try. All right, let's take a look. I learned a new feature here. Oh, I got a chat message. Maybe it's a question. Oh, thumbs up. So, new feature, I can hide my work while I'm working and then just show you the answer. So I don't have to waste your time, solve it in front of you. So there's the answer, 13.42 at an angle in the second quadrant of 21.37. How did we do? Although I lost everybody. There they are. How did we do? Good? Oh no, not the bowling ball phase. 4 people got it right? That's it? 4? I guess we got to do another one then. Where are the questions?
Wait,
What's up?
I did the exact math, but I got a different answer.
Oh no, maybe I put it in my calculator wrong.
Unless I could be completely wrong.
Well, you have the same numbers, 12.47 and 4.97?
No, that's probably where I messed up at. Let's see, 20. I have this. Oh, okay, I see why. Okay, I mean, I accidentally had my b for negative 20 cosine positive. That's why.
Yep, that'll do it. That's the big problem. That is the number one way you get these wrong, is if I don't mean to single them out, but
Oh, you're fine.
the biggest issue that people are going to have are losing signs along the way. If it helps you, if you're losing signs, when you're doing this step here, like for B, like this step right in here, draw it out. Don't be afraid to take the extra 10 seconds and draw it. Maybe that just drawing it into the left, you'd be like, oh, that's negative. You know what I mean?
Yeah.
Something you could do too to help you remember.
I think what happened was I erased something and I erased the negative out and just never put it back.
Yeah, those thinking negatives, they'll get you. So, like on the test, that'll be where you would get partial credit. If you forgot to put a negative sign in, I would recognize that and
Got you.
give you points. Let's try one more. We got a little bit of time here. And if you think you know it, you can go. But I think, like I know the MET students, this should be pretty easy for you because you had a whole class on this last semester. So you guys are free to go. But those of you who need extra help, we're going to do one more. And if anybody has questions, you can ask at any time.
Oh,
Interrupt.
I have a question for the test. What decimal places do you prefer us to round to?
2. Everything's going to be to 2 decimal places.
Okay, thank you.
Anybody else have any questions or anything? All right, we're going to do one more. Those of you who want to stay can stay. I can't even see if you're here or not. I'm just going to be doing this blind. Let's do a circle. Do 3 angles. All right, so A, B, and C, add them up. Find our resultant, R of A plus B plus C. All right, I got finished there. Give you a minute to finish up.